This lesson is on graphing quadratic functions in the form of y equals ax squared plus bx plus c. Recall that a y-intercept is the y-coordinate of the point where the graph intersects the y-axis. The x-coordinate of this point is always 0. For a quadratic function written in the form y equals ax squared plus bx plus c, when x equals 0, y equals c. So the y-intercept of a quadratic function is c. Y equals x squared minus 2, the negative 2 is the c value. That's the point where the parabola is going to hit the y-axis. For y equals x squared minus 4x plus 4, 4 is the c value. So that's the point where the parabola would hit the y-axis. For y equals negative 2x squared minus 6x minus 3, negative 3 is the c value. That's where the parabola will hit the y-axis. You'll notice in all of these, if you plugged in 0 for x, you would just be left with the c value, which is what makes it the y-intercept. Graph y equals 3x squared minus 6x plus 1. Step 1 is to find the axis of symmetry. We're going to use the equation x equals negative 1 times b divided by 2a, and we're going to substitute 3 for a and negative 6 for b, and then simplify, and we get 1. So the axis of symmetry equation is x equals 1. That's going to be the middle of where the parabola is. Since the middle of the parabola is also where the vertex is, we know that the x value of the axis of symmetry, the 1, is the x value for our vertex. So in order to find the y value, we're going to plug the x value, 1, back into the original equation and simplify to solve for y. And we get negative 2. So the vertex is 1, negative 2. Now we're going to find the y-intercept. We look at the equation y equals 3x squared minus 6x plus 1 and identify the value of c. That would be the value if we plugged in 0 for the x. So the y-intercept is 1. The graph passes through the point 0, 1. Now we're going to find 2 more points on the same side of the axis of symmetry as the point containing the y-intercept. Since the axis of symmetry equals 1, we're going to choose x values that are less than 1. So we could choose negative 1 and plug it in and solve, and we get 10. So it'd be negative 1, 10. And then also we could choose negative 2 and plug it in, and for y we would get 25. So the other 2 points we could graph are negative 1, 10 and negative 2, 25. Step 5, graph the axis of symmetry, the vertex, and the point containing the y-intercept with the other 2 points. So the axis of symmetry is the green dotted line. We draw it as dotted because it doesn't actually exist as part of the graph. It's just helpful for us to know where the center of the graph is going to be. We graph the y-intercept, which was 0, 1, and then we graph the other points, negative 1, 10 and negative 2, 25, and then the blue point down at the bottom, that was the vertex that we found. Now we can reflect the points across the axis of symmetry. The parabola is a symmetrical figure, so everything is going to mirror itself on the other side. So if we mirror the points across, and then we connect the points with a smooth curve. Because a parabola is symmetrical, each point is the same number of units away from the axis of symmetry as the reflected point. Graph the quadratic function y equals 2x squared plus 6x plus 2. This one's for you to try, and then you can check back for your answer. So step 1, we're going to find the axis of symmetry using the equation x equals negative 1 times b divided by 2a. We're going to substitute 2 for a and 6 for b, and then simplify, and we get negative 1 1/2. So the axis of symmetry is x equals negative 1 1/2. Now we have to find the vertex, so we're going to plug that back into the equation for x, and we get, simplify, negative 2 1/2. So the vertex is negative 1 1/2, negative 2 1/2. Then we're going to find the y-intercept. So looking back at the original equation, we have y equals 2x squared plus 6x plus 2. If we plugged in 0 for x, we would end up with just the c value, which in this equation is 2. So the y-intercept is 2, which means the graph passes through the point 0, 2. Now we have to find 2 more points on the same side of the axis of symmetry as the point containing the y-intercept. Since the axis of symmetry is x equals negative 1 1/2, we're going to choose values that are greater than negative 1 1/2. So we're going to have x equal negative 1, and we plug that in and solve for y, and we get negative 2. And then we could also have x equal positive 1 and plug that in, and y would equal 10. So So the other 2 points would be -1, -2, and 110. Now we're going to graph the axis of symmetry, the vertex, the point containing the y-intercept, and the other 2 points. So the axis of symmetry is the green dotted line. It's at -1 and 1/2. The vertex is -1 and 1/2 and -2 and 1/2, so that's the blue dot. And then the other 2 points were -1 and +1, so it's 1, -2, and 110. Now step 6, we can reflect the points across the axis of symmetry, and then we'll connect them with a smooth curve. Graph the quadratic function y plus 6x equals x squared plus 9. This one's for you to try, and then you can check back for your answer. Please note that the equation is not currently in y equals ax squared plus bx plus c form, so you want to move it into that format first before you start graphing. So we're going to rewrite it in standard form, y equals x squared minus 6x plus 9, and then we're going to find the axis of symmetry using the equation x equals -1 times b divided by 2a. We're going to substitute 1 for a and -6 for b, and then simplify, and we get 3. So the axis of symmetry is the equation x equals 3. Now we're going to find the vertex. We're going to plug 3 back into the equation for x and solve for what the y value is, and we get 0. So the vertex is at 3, 0. Now we're going to find the y-intercept. We're going to look back at the original equation, y equals x squared minus 6x plus 9. We have to identify c. That would be the value if we plugged in 0 for x, which is 9. So the y-intercept is 9, and the graph passes through 0, 9. Find 2 more points on the same side of the axis of symmetry as the point containing the y-intercept. Since the axis of symmetry is x equals 3, we're going to choose x values less than 3. So we're going to have 2, plug that in for x, solve for y, and we get 1. And then we're going to have 1, plug that in for x, solve for y, and then we're going to get 4. Try to pick numbers that are really easy. If you didn't pick these exact numbers, that's fine. So the 2 other points, 2, 1, and 1, 4. Now we're going to graph the axis of symmetry, the vertex, the point containing the y-intercepts, and the other 2 points. So the axis of symmetry is the dotted green line, x equals 3, so it's a vertical line going through 3 on the x-axis. We're going to graph the vertex, which was at 3, 0, so that's the blue dot. And then we're going to graph the y-intercept, that's the red dot, at 0, 9. And then we're going to graph the 2 other points we chose, which were 2, 1, and 1, 4. Now we're going to reflect the points across the axis of symmetry and connect the points with a smooth curve. The height and feet of a basketball that is thrown can be modeled by f of x equals -16x squared plus 32x, where x is the time in seconds after it is thrown. Find the basketball's maximum height and the time it takes the basketball to reach this height. Then find how long the basketball is in the air. So the first thing we're going to do, understanding the problem, the answer includes 3 parts: the maximum height, the time to reach the maximum height, and the time to reach the ground. We're going to list important information. The function is f of x equals -16x squared plus 32x, and it models the height of the basketball after x seconds. Make a plan. We're going to find the vertex because that will be the maximum height of the basketball, the y value of that, and the time it takes to reach it are the coordinates of the vertex. The basketball will hit the ground when the height is at 0, so we're going to find the zeros of the function, and we can do this by graphing. So step 1 would be to find the axis of symmetry. We're going to use the equation x equals -1 times b divided by 2a. We're going to substitute in -16 for a and 32 for b and simplify, and we get 1. So the axis of symmetry is x equals 1. Now we're going to find the vertex. We're going to plug 1 back into the equation for x and simplify and solve for y, and we get 16. So the vertex is 1, 16. Now we're going to find the y-intercept. Remember, we're identifying it as c. This equation didn't have a number there, so you can write it as +0 if that's helpful. So the y-intercept is 0. The graph passes through the point 0, 0. Now we're going to graph the axis of symmetry, the vertex, and the point containing the y-intercept, and then we're going to reflect the point across the axis of symmetry, connecting the points with a smooth curve. So the axis of symmetry is the green line, and the vertex was 116. Our y-intercept was 0, 0, and if we reflect that across, since it was 2 away, it's 2 away on the other side, so it's 2, 0. The vertex is 116, so at 1 second, the basketball has reached its maximum height of 16 feet. The graph shows the zeros of the function are 0 and 2. At 0 seconds, the basketball has not yet been thrown, and at 2 seconds, it reaches the ground. The basketball is in the air for 2 seconds. Remember, the vertex is the highest or lowest point on a parabola. Therefore, in the example, it gives the maximum height of the basketball. As Molly dives into her pool, her height in the feet above the water can be modeled by the function f of x equals negative 16x squared plus 16x plus 12, where x is the time in seconds after she begins diving. Find the maximum height of her dive and the time it takes Molly to reach this height. Then find how long it takes her to reach the pool. This one's for you to try, and then you can check back for your answer. So to understand the problem, the answer includes 3 parts: the maximum height, the time it takes to reach the maximum height, and the time it takes to reach the pool. Important information: the function is f of x equals negative 16x squared plus 16x plus 12, and it models the height of the dive after x seconds. Make a plan. Find the vertex of the graph because the maximum height of the dive and the time it takes to reach it are the coordinates of the vertex. The maximum height will be the y, and the time it takes will be the x. The diver will hit the water when the height is 0, so find the zeros of the function. You can do this by graphing. Step 1, find the axis of symmetry. We're going to use the equation x equals negative 1 times b divided by 2a. And we're substituting in negative 16 for a and 16 for b. When we simplify, you get 1/2, or 0.5. So the axis of symmetry is x equals 0.5. Next, you find the vertex. You plug 0.5 back in for x and solve for y. Simplify, and you get 16. So the vertex is 0.5 and 16. Now you're going to find the y-intercept. Looking back at the original equation, you want to find the value of c, which in this equation is 12. So the y-intercept is 12, and the graph passes through the point 0, 12. Step 4, find another point on the same side of the axis of symmetry as the point containing the y-intercept. Since the axis of symmetry is x equals 0.5, we're going to choose an x value that's less than 0.5. So we chose 0.25, or 1/4. Plug that back into the equation and solve, and we get 15. So another point on this parabola is 0.25 and 15. Now we're going to graph the axis of symmetry, the vertex, the point containing the y-intercept, and the other point. Then we're going to reflect the point across the axis of symmetry and connect the points with a smooth curve. So you can see that the axis of symmetry is the vertical line in green. The vertex was 0.5 and 16. One of the other numbers, negative 0.50 and 1.5. The vertex is at 0.516, so at 0.5 seconds, Molly's dive has reached its maximum height of 16 feet. The graph shows the zeros of the function are negative 0.5 and 1.5 seconds. At negative 0.5 seconds, the dive has not begun, and at 1.5 seconds, she reaches the pool. Molly reaches the pool in 1.5 seconds.